Yep. Cool. All right. Good. Well, but I see no video. Why do I see no video? Where's the video? Oh. Oh. Is it working? Come on, YouTube. Oh, I'm not plugged in. Then the notebook will remember how to be a notebook. There, that's the performance I expect. Okay. Looking good. Oh. Okay. All right. Cool. So, good. Give me just a second to check a couple more things.
Especially when you're doing it for the first time. It's not easy.
And audio test. Test. Good enough. Okay. Everyone good? All right. We're gonna go ahead and get started then. If you want to follow along with the second half, where we're going to do Pytest stuff, please make sure you have Python installed already. We will not have time for me to help you set up Python. Okay. So, hello and welcome. I'm Beege. This is Code Soul. Code Soul is a nonprofit group that does IT education in Seoul. We have a Discord server, which we use to chat and ask for help with code questions and share materials. If you plan on following along with the workshop portion of today's presentation, I strongly recommend scanning that QR code or going to that web address, because that is how I'm going to share the code and the slides, okay? So, today we're going to cover software testing and Pytest. Today's workshop will be split in half. The first half will be just general software testing. So if Python is not what you're doing, this is still relevant to you. And then the second half will be using Pytest specifically for testing Python, okay? If you are worried about remembering stuff, or if you're worried about getting the material, this is being streamed on YouTube right now, and it will be recorded, so you can always reference it later. And we also share the presentation slides. All right? So any questions before we get started? Does anyone else need to scan the QR code? Yep, waiting just a moment for that. All right, cool. Okay, so let's go ahead and get started. So my usual disclaimer, I am not an expert, okay? This is just my knowledge that I use for work daily. Well, not so much anymore, but some things may be missing or outdated, but this should be accurate enough for you to get started, okay? I have tested everything. Everything should work. So let me fix this right here. There we go. Okay. So the agenda for today, we're going to be busy, okay? We're going to go a little bit fast, especially during the Pytest portion. So we're going to cover why do we do software testing, okay? It's a little bit obvious, but I want to go over some details because, hint, when your project manager is like, this needs to be done now, and you're like, wait, I need to write tests, and they're like, no time for tests, you can be like, wait a second, but we get this if we write tests. So really it's just giving you arguments to give you time for testing. We'll go over the different types of tests. There are many. We'll go over when to test, how to test. We'll talk about test coverage, which I'll explain when we get to that section. And then we'll get into the second half, which is Pytest, a library specifically for testing Python code. We'll go over setting up and writing a basic test, and we'll go over the setup and teardown operations in Pytest, which, again, I'll teach you about. And then we'll end with mocks, and then, if any time remains, we'll have discussion. If you feel like, oh wait, there was a bunch of questions I wanted to ask, but now the presentation is over, usually after events, we all go get chicken together. So if you want to come get some chimek and you want to ask questions, that's a good time. CodeSoul does pay for food, so it costs you nothing, okay? So let's dive in. Or any questions about the agenda before we get started? Cool. Normally, I wait a really long time after asking if there are any questions because I want to give people time to, think of the question and then summon up the courage to actually say something. But because we have a lot of material today, I'm going to go fast. So if you have a question, be ready. All right, so why testing? So for those of you who've been here before, I'm trying to change my presentation style. I got feedback that there was way too much text on the screen and it made it hard to pay attention. So if you're worried about wait, there's no information here. When I share the presentation slides with you, all the information that I'm speaking about is in the notes, okay? So don't panic if you're like, wait, I'm not going to remember everything, or I don't want to watch the whole video again. It's in the notes. So the big thing is confidence. The product needs to work, all right? You need to make sure that it works. You need to have tested it, but testing things by hand sucks. It takes time. It's not easily repeatable, and time is money. And when your project manager is like, hey, I don't have time for you to write tests, and it's like, well, if you give me 1 hour to write tests now, it's going to save me 30 minutes of testing this thing every release for eternity, right? So that's a pretty good argument. But the main thing is that you've run the code multiple times, okay? Basically, every time you test, you should test all of your code, and that way you make sure stuff runs despite any changes you've made. And that's better than you testing the entire application after each individual change. The next major point is efficiency. Testing by hand is error-prone, slow, and boring, right? So usually, when we do automated testing, it's one command, you run the one command, it tests everything, and you're done. Or ideally, it's a byproduct of another command. For example, when you commit your code, you can automatically run tests before you commit. You don't even have to run a command. You're already committing, it tests the code for you. We'll cover that. It also makes refactoring easier. If you're trying to improve existing code and you're not trying to change the output, this is perfect because the test is already testing against the output. So then as long as the test passes, your refactoring is okay, right? You haven't broken anything because the test still passed. Quality is a big thing. It establishes a level of quality for your code, right? Especially if you're on a team where you have a junior engineer who goes really fast because they're like, speed is everything. And then half the time what they build is broken, right? But if you don't accept their code without an automated test for it, you guarantee at least some level of quality. Big thing is accountability. This encourages a good developer culture, okay? If engineers must test their code, they want to make sure that their code is easy to test, right? You are holding them accountable that you've tested this code, right? And if it's not good in production, your test code is wrong, you need to go fix your test code, okay? In the old times, it used to be like you would have dedicated QA people, dedicated testers, right? Or ideally, you should still have QA people. But the workflow was developers built the thing, and then they often didn't test and just kicked it over to QA, the testers, quality assurance. And then QA would run through things, and then they'd fight with the developers. The developers would be like, I don't have time for this. The deadline's about to pass. Just say it passes, right? And it's easier to convince a person than it is to convince code. You can't convince code. It gives you like binary success or failure, right? So you basically replace that problem of developers strong-arming QA testers, because that used to happen quite often. That said, automated tests are not a replacement for QA. I want to emphasize that very clearly. just because you have automated tests doesn't mean you should get rid of your QA people. You still need them because engineers inherently think differently from testers. Testers are always, like, the kind of person that makes a good tester, they're always thinking about how to break stuff, right? Engineers don't think that way. We think about how to build stuff, right? So we're not as creative as testers are when it comes to figuring out ways to break an application, okay? So if someone's like, oh, now that we have automated tests, let's get rid of QA. Don't let them do it, okay? A big thing too is consistency, okay? If you make certain changes, your tests ensure that your application behaves in a certain way, okay? Because the test code has not changed, right? So in this way, you ensure consistent behavior despite any changes you make. Unless, of course, you change your test code, but that should be in response to any features that you add. And then I hesitated to put this one on here. Test code can also act as documentation. Now, similar to the QA thing, test code is not a replacement for documentation. Hi, welcome. Oh, hey, Alex. Pretty good. Good to see you.
Sorry to interrupt.
Alex is a co-founder and the legal head of Code Soul. So, yeah, welcome, Alex. And he never comes to Saturday, so good to see you. I like it. So, what were we saying? Right. So, for example, let's say you're publishing a library for use by other engineers, your test code can be an example of how to use that library. Quite simple. Now, granted, you still want to have documentation, right? MKDocs is a great tool. But, if all else fails, people can check this. Questions about these kind of qualities and arguments for using software testing? Cool. Again, I imagine if you're here, you probably have thought of this a lot already, but this can give you basically talking points with your manager, with your project manager, or whatever. So, one more thing. We are pressed for time, and I get excited about this stuff, so I speak very quickly. If I'm speaking too quickly and you cannot understand me, be like, Beege, you're talking too fast. I cannot parse English that quickly, and I'll slow down, okay? Going forward. So, what are the different types of tests? There's a lot. The most basic one that you'll hear about most often is called unit testing. Unit testing, you're testing a single function in an isolated way, okay? So if that function calls another function, or if that function connects to a database or something, you section it off, you isolate it, okay? You use that using something called mocks, and we'll talk about mocks later, okay? Now, unit tests, because they're testing individual functions in isolation, and because you're avoiding all the stuff like database connections and file operations and all of this, they're meant to be fast, okay? So you should run them very often. Basically, every time you make a change, run your unit tests. It's like a one-line command and you're done, all right? Next up is integration tests. Integration tests are a little more complicated. This is when you integrate with other systems, whether it's other code or whether it's an external thing like a database or a file or something. These are covered by integration tests, and these require a bit more effort because you don't want to test with like the production database, right? And that means you have to have a development environment, right? But then is it a shared development environment? Do you set up a local development environment? How do you do that? So this requires a bit more DevOps stuff, or what some people call developer experience things. And we'll talk a little more about that later too. Next big one, and one of my favorites, especially that I'm a PM now, regression tests. Regression tests, basically, once you encounter a bug, the first thing you do is write a regression test. You write a test that reproduces the bug. As long as the bug exists, the test fails. Okay? Once you have fixed the bug, the test should pass. Pretty simple and straightforward. Now, the purpose of this, you might be like, well, if I fix the bug, then why do we need to keep the test for it? Because if the bug happened once, it might happen again. Maybe someone needs to refactor that code, and they're like, oh, why is this thing here? And then they remove your code that fixes the bug, and then they're like, if the test wasn't there, they'd be like, oh, I cleaned up unnecessary logic, and then they'd go about with their day. But if you have a regression test, and that test should have some comment of like what bug it's fixing, why the bug happened, or maybe ideally a link to a Jira issue or Trello or Asana, whatever you're using for task management. They can see, oh, this is a regression test. Oh, that logic is necessary. It fixes this bug. Oh, I can see in the task management, okay, that's the bug it fixes. Okay, so regression tests, very nice. Now, one thing to note is that not all bugs are code bugs. Sometimes you have data bugs, or sometimes you have environment bugs, okay? Now, you should still have regression tests for kind of checking that your software handles bad data properly or handles a bad environment properly. You still want regression tests for those. But if your code does handle that stuff properly, but then maybe something about the testing environment or something about the production environment is not configured properly, or there's bad data, there's other ways you can handle that. Okay, and we'll mention that later. Okay. Next is functional tests. This tests system-level functions. Okay, so unit tests and integration tests test individual functions in your code. Okay, functional tests test kind of a workflow, like a login, right? If I send a login request, you get the. I'm thinking from a backend perspective, but let's say the front end sends a login request. The backend will have, some URL handler that'll send to some view, that'll send to some controller, or maybe a service, and then it'll go to the data layer, and that whole thing is a functional test, okay? And that's just nice for making sure that everything hooks up properly, right? Because if you're doing unit tests, you're not checking if function A is calling function B properly, because you've isolated them, right? Functional tests help you catch that. Now, the next one, there's a little bit of confusion sometimes between functional tests and end-to-end tests. Functional tests are usually single technical operations, okay? End-to-end tests are a little different. End-to-end tests test user flow operations. So using login as an example, from a user perspective, when they log in, first they visit the main page. Then they click the login button. Then they enter some login inputs. Then they click the login button. Or then they click the submit login info button, right? And then, the page refreshes with, their profile info, maybe some recommendations, this kind of stuff. That may be many calls to the back end, right? And an end-to-end test would test all of that, okay? So that's kind of the difference between functional and end-to-end. Functional is a system interaction. End-to-end is a user interaction, which may have many system calls. Next up is smoke tests. This is very important, but usually not too big of an issue. Smoke tests are usually the kind of basic critical tests that you do when you release or deploy your software. I haven't heard of these being automated too often, but theoretically you could. They're meant to be just a very small number of them, because you don't want to take too much time when you're deploying, right? Because deploying may involve downtime, or if there's a bug, you want to be able to roll back quickly, right? So you want to keep your smoke tests kind of the minimal required bit to make sure that the application works. And then last one is load tests. This is much, much more advanced, and this is not applicable to everyone. So like Kakao Talk may do load tests, right? But some tiny service that no one knows about may not use load tests. Load is referring to the amount of traffic or the amount of operations, all right? So load testing would be, hey, let me set up the entire application and let me see how it handles, 1 request per second, 10 requests per second, 100 requests per second, right? And keep scaling up to see at what point does it fail, and does the point that it fails at acceptable, and how exactly does it fail, right? Was it the load balancer? Was it the database? Was it the API server? Was it the auto-scaling system was too slow? Whatever, right? Again, this is much more advanced. This is only for more mature applications, and not every application will need it. It's also very expensive, because you need to generate that load, right? And ideally, you'll need to do some scaling, right? So these kinds of things. Any questions about the different types of tests? We haven't gone into a lot of detail, but yeah. Cool. We're going to go over a few of them individually. So if you have more, if things are a little unclear, you can clarify them.
I have a question.
Yes.
For regression tests,
Hmm.
who would you say would be responsible for writing regression tests?
The engineers.
Okay.
The engineers have to fix the bug, right? So the engineer writes the tests.
Got it. Thanks.
So like I said, when you as an engineer are fixing a bug, ideally the first thing you do is you write the regression test to reproduce the bug. Okay, so a bug report comes in, you write a test. Cool, I can reproduce the bug. Okay, let me find the logic, fix it. Test passes, bug done. Does that answer your question?
Yep, that's enough.
Cool. Any others before going forward? Cool. All right, so when do you test? Always. If you're not testing already, you can always start now. You don't have to test the entire application, right? Or you don't have to like stop everything you're doing and write tests for your whole application. I actually didn't put this in the notes, but I'll add it afterwards. One strategy that you can do, and that I'm actually doing on my team too, we have one application that we inherited. It has 0 tests, none at all, and it is not even a little bit stable. But it's a big application. So what we're starting with is anytime we make a change, that change has tests. Eventually, we're going to have to change every part of the application, right? Or eventually, every part of the application is going to encounter some bug or something. And so over time, the number of tests and the amount of the application covered by tests will increase naturally over time. Okay? So don't feel like, oh, we have to write tests for everything right now. No. You can do it in pieces. But when do you actually run your tests? Well, you can do it on commit. Usually you do your unit tests and your regression tests, depending on if your regression tests can be done in unit tests. Some regression tests have to happen at the functional test layer, and if so, just do them then. And the unit tests, again, should be very cheap. They should be very easy to run. So there are these tools to run scripts whenever you commit. Git has something called a pre-commit hook. It has a whole bunch of different types of hooks, but the key one here is pre-commit. If you're in the JavaScript TypeScript ecosystem, there's a tool called Husky that allows you to configure scripts for pre-commit, including running your tests. If you're not in the JavaScript TypeScript community, I like pre-commit. It's written in Python, but that doesn't really matter. You can run it with anything. It has just a basic YAML configuration file where you can say, hey, run all these things. It also has other nifty stuff you can do, like automatically running linting, automatically doing builds and all that kind of stuff, whatever you want to do. It just runs scripts. When you're doing pull requests is another good opportunity to do testing. So this is where you would usually do your integration tests, your functional tests, and your end-to-end tests, okay? Because these tests are a little bit more expensive. And by expensive, I mean they take more time, right? So you don't want to wait like 2 or 3 minutes after every change. That's going to kill your workflow, right? That's going to take you out of a flow state. So you usually do these on pull request or merge request if you're in GitLab land. And that's usually done with CI. If you're not familiar with CI, we have a presentation for that. And if you want to see the slides, just message me on Discord and I can share them with the whole group again. And then you also do testing on release. That's where smoke tests come in. And then when you do major changes, you should do load testing again. Okay, if you're doing load tests. Okay. Questions about this side of things? So far, so good.
What you mean by release? Is it like a minor version update? I'm guessing major change would be like a breaking change that's in version 2 to 3, and if you do semantic versioning. But,
yeah.
Would release be just like a bug fix or something like that?
Would a release? So release is any time you deploy your software for others to use.
So would it be, from a Git perspective, would it be when you add a tag to a particular commit?
If that is your release workflow, then yes.
Okay.
Yeah. So it's basically anything. So if you're using CD, continuous delivery, anything that triggers a deploy would be on release.
Got it.
If you're not using CD, anytime someone goes and puts your code on the production servers would be a release. Or if you're publishing a library for other groups, anytime you do a tag to trigger a new package build would be a release. Okay?
That makes sense.
Cool. Other questions? Cool. All right. So then, okay, all that's great, but then how do you tell about how to do all these types of automated testing, the different kinds, but how do I actually write tests? Most of that we're going to cover in the second half, but if you're not in Python land where we're doing stuff today, I've linked to a couple of options. Now, this is not comprehensive. This is not everything. These are just the ones I hear of most commonly, okay? So Google around if you're not happy with these. Especially JavaScript. JavaScript has a whole bunch of options, but usually when I talk to people, I hear them using Jest. That said, one thing I didn't add in or did not put in here that I will add later. If you're doing front end, there's a really nice tool system called Cypress that can do like visual diffs of changes and stuff. That one's really slick. It's a little difficult to use, but once you get the hang of it, it's really nice for front end. But otherwise, anything logic-based, these will usually work. Note that C#, Golang, Ruby, Flutter, all those have testing libraries built in. Actually, most languages have some kind of testing library built in, but often a third-party library does a little bit better for testing. For example, Pytest has a unit test, Python has a unit test module built in, but most people use Pytest because it's better. So yeah, this is mostly just for documentation, but if your language is not on here, it'd be like, Beege, why is there no love for Hodor language? Then I'll add it in there, just message me. So, okay, cool. Given that, how do we actually, write the tests? For unit tests and regression tests, again, you only test the target function. You'll often hear this, if you read more about unit tests, you'll often hear it called the function under test, or they'll abbreviate it as FUT. Again, this is to make isolating problems and bugs faster, okay? Because then you know which specific function failed. It also keeps your tests running fast if they're not making a whole bunch of external calls. The key thing is to use mocking. I mentioned this earlier, but what is mocking? Mocking is basically replacing a function with a fake function, okay? So let's say I have a function that gets a list of users from the database, okay? And obviously that has a database call. But what I might do to make it a unit test is I might use a mocking library to take my database library, grab the query method, throw that away, and substitute a fake method that returns some data that I predefined to simulate a successful database query. Okay? So that's what mocking is. You basically hijack an existing function, change its output, and then you use that in your test. And you can do that for libraries or other modules within your software. You can do it for external systems, whatever. It works for everything. Different languages do it differently. You'll have to read up on whatever framework you're using. Integration tests, functional tests, end-to-end tests. Key things, you want to randomize your fake data. Okay? You do not want to you could test with copies of real data, but you don't want to test on production, obviously. But if you are using fake data, you should randomize it. This prevents any collisions. This also prevents kind of artifacts from old tests and things like that, although you should be cleaning up after yourself, which we'll talk about in a moment. There are lots of libraries for generating fake data. Lots and lots and lots and lots of them. If you've ever seen those like kind of name generation things where it's like adjective and then person name or animal name or something like that, that's a very common fake data generation library. I don't remember the name, but you can just Google for it. Use Docker when you're doing integration tests. Unless you're doing a shared system, there's debate about whether it's better to do it on a shared system or local or whatever. due to, if you're doing a shared system, you can have it configured more like production. If you're doing it in Docker, it's not going to be exactly like production unless you're using Kubernetes. But the reason for using Docker is because if you need to run your integration tests locally because you're trying to reproduce a problem, then you can do that because you can install Docker on your notebook. You can set up all the services like your database, your message queue, maybe some other microservice or whatever. You can set them all up with Docker, run your integration tests. Everything works locally, just like in your CI or maybe even production if you're on Kubernetes. Now, this does require development effort. Ideally, you have someone with strong DevOps knowledge who can help you with this, or maybe you have that strong DevOps knowledge to set up such a thing. We also have a Docker presentation, so if you're curious about that or need help, we can share that presentation with you. Additionally, if you are, let's say like there's a bug report, and you don't have enough information to reproduce things, to write a regression test. If you do have your environment set up via Docker, you can just set up the whole environment, and then you can do by hand testing to help you figure out where the problem is, and then you can write your automated test based on your hand testing. I have done that a lot. It's very useful. I strongly recommend it. But big thing. When you're doing these integration tests and functional tests, do not rely on tests to generate data for each other. So let's say you have like a registration, a new user registration test, and then a login test. Do not rely on, hey, let me run the registration test first to create a user, and then let me do a login test based on that user info. Don't do that. It will cause you a world of pain. Because let's say that this new user registration test has like 20 tests that all depend on its data. And then this test is broken. Is it the registration test? Is it some other thing, some other library that's broken? You don't know. You have to go through each thing and figure out where it is. So if you make sure that you generate fake data for each individual test case, you prevent this problem of dependency hell. Okay? Additionally, sometimes test runners look like they guarantee tests run in a certain order, but it's just that's how it happened to run on your computer. And they're not guaranteed to run in a certain order. So what could happen is maybe if the tests run out of order, you may get false test failures, or even worse, you could get false test successes, because then there's a problem and you don't know it. So do not make tests rely on each other's data. Please. That will make your life way better. And then for all of the above, there's this idea of setup and teardown. We've been talking about mocks, we've been talking about fake data. Setup and teardown is how you do these things. Setup and teardown are usually functions that are run before your tests, either before the entire test set or before individual tests. And then teardown is either after the whole test set or after each individual test. And you can use that to set up data and clean up data. You should usually clean up your fake data after running a test. Or if your test generates data, you should clean up that generated data. This keeps your testing environment clean, and it prevents tests from being influenced by each other. Okay? Hence the bullet point before. Okay? So does that all make sense so far? Cool. How are we doing on time? We're doing okay. So cool. That's nice on like how to write those individual types of tests. But how do I know what tests to write? There's a few different ways. There's a few different categories of tests. Now, granted, only happy path testing is the one that I hear used very, very commonly. These other ones I kind of made up, but it's how I think about them to categorize things. Happy path testing is if all the inputs are correct and all the systems are working properly, this is how the function should behave. Okay? So that's basically just testing that things work the way you expect them to. That is happy path testing. At a minimum, have happy path testing, okay? Because it just makes sure the application behaves. And under that why testing stuff, happy path testing will get you most of that, okay? But going beyond that is where you can develop a lot of confidence and have really strong confidence, I'm reusing words here, in the quality of your system and of your tools. Input testing is a big thing. For example, let's say you have some function that calculates some probability of something, right? And it takes in a bunch of numbers. Try giving it a negative number. Try giving it a decimal. Try giving it a huge number. Try giving it something that's not a number, okay? Mess with the inputs. Try to break it. Remember earlier, I was talking about how engineers think in terms of building. Testers think in terms of breaking. Try to think, what kind of weird stuff can I give this to break it, okay? Input testing, giving it all sorts of different weird, unexpected inputs and making sure the system handles it properly can make sure that things work. Because in the real world, nothing goes according to plan, right? Also, if you want to get into like funky stuff, you can give it like binary inputs, or you can even give it like, if you expect some kind of data structure, like maybe you expect a dictionary of a certain format or a map of a certain format, depending on your language. Give it an improperly formatted data structure and see, does it just give a random key error with a meaningless error message? And you're like, I don't know what this means. I wouldn't know how to fix this if I saw this in production. Or does it go, hey, the input to this function was bad. It expected this kind of thing, but it wasn't there. Oh, okay, now I have an idea of where the problem is and how to fix it. Okay? Man, this next one, like when I wrote it, I was like, man, if I'm not really clear in my notes about what I mean by dependency, I'm going to confuse people. And I confused myself. That's right. Okay, I'm going to rewrite this later because even in the notes it's not entirely clear. But I'm calling this dependency testing. I should probably come up with a better name for it. But let's say that you query the database in one of your integration tests, right? And you expect some kind of output back from the database. You should write a test for what if the database gives you an error? Or maybe you time out trying to connect to the database. Or maybe the database gives you some weird data, right? You should test these kinds of things too. Test the dependencies of the functions you're testing to make sure, again, that your application handles the errors gracefully, okay? The whole application shouldn't just crash and then the users are like, what happened? They should get some kind of meaningful error to them, and there should be some kind of meaningful logging for you to go fix the bug later if you find a bug, okay? And then, I'm not sure if I should have split this one from dependency. Oh, the slides are wrong. Okay, hold up. 1 second here. There we go. Okay, try this again. Okay. Resilience. I'm calling this resilience testing. This is basically, what if an external service is down, right? So if the database goes down, does it tell the user, my SQ cannot connect? The user's going to be like, what the hell is that? But if you say, hey, we're having some kind of internal problem, please try again in like 10 minutes, the user will be like, oh, okay, I'll try again in 10 minutes, right? And then again, make sure you log stuff. So especially like if you do a lot of microservices, or if you rely on like another team's systems or services, or even worse, like some third party, some other company's system or service, you want to like test their shit too, okay? Because it's going to go down and it's going to cause all kinds of problems. For example, in my previous company, we used Google Dialogflow, which is a text-to-speech and speech-to-text machine learning system. We used it to do like an AI customer service kind of thing. And one day, Dialogflow went down for 3 hours. And for the first hour, we had no idea what the problem is. We're like, we're sending stuff to Dialogflow. Are we sending stuff incorrectly? Are we not connecting properly? Is there some kind of firewall rule down? Or firewall rule incorrect? It didn't even occur to us like, hey, maybe Google's system is down. And that's what it ended up being. But if we had a test to check for that, and if it gave us some kind of message of like, hey, everything is working properly, we made a request, we never got a response, that helps us, work with Google, work with our customers, log stuff, all that. Okay? Questions about these? Cool. Let me fix this real quick because I redid it. Ah, come on. There we go. All right. So, so that's it on kind of like how to write tests. And now on to code coverage. So code coverage, again, has to do a little bit more with confidence. Code coverage answers the question of how much of my code is tested. Okay? Now you might be thinking, how do you measure that? Well, there's usually two key metrics. One is just by lines of code. How many lines have functional code in them, and what percentage of those lines are executed when a test is run, and which functions have a test checking them. Functions is usually useful to figure out how much of your application is tested, obviously, but that's more kind of like the logical application layer. Lines is usually, most of the time when I see people writing tests, they'll often skip testing edge cases, so testing bad inputs, all these kinds of things. And that's usually when you'll see like the number of functions very high, but the number of lines very low, because they just skip testing all the error handling, right? So that's one thing to look out for. But this kind of gives you an idea of, you know, how much of your code is tested. And a lot of people initially go, oh, what's a good percentage for test coverage? Like, should I try to have 90% of my application tested? And there's not a good answer. It depends on your system architecture. It depends on your engineers. It depends on the libraries and frameworks you're using, all these kinds of things. Big thing is 100% test coverage is not realistic. It's not worth it either. I've seen some applications be really stable and they only have 60% test coverage. And I've seen some applications that are absolute trash and they have 90% test coverage. Hint, the 90% test coverage case, they had like no error handling, right? So high percentages on everything. And I'm doing this a little out of order, but a big thing is that when you enable test coverage in your development environment, like let's say you're using PyCharm or IntelliJ or Visual Studio or something like that, if you enable test coverage, if the IDE understands your test coverage output, it will actually show you which lines are covered and which lines are not while you're browsing the code. And that's really nice because then you can see like, oh wow, none of our error handling is tested. Got it. Okay, let's go fix that. Or, oh, we tested this logic path, but not this logic path. We tested when we get a Korean user, but not when we get a foreign user, which I guarantee there's a lot of that kind of stuff. And then the nice thing with test coverage is that you can generate differences between test coverage reports. So if you record your test coverage outputs, you can see, hey, if I added this change, does our total test coverage go up or down? Right? Did we cover more? Did we cover less? And that helps you know, like, especially again, if you have junior engineers who are just trying to go fast, that helps you know, like, hey, does this new code not meet our standard of testing, right? Are there not enough tests written for this code compared to what we already have? And that's useful for, again, tracking quality, and saves you a lot of time of going through things one by one. You can just look at an overall summary. One tool I really recommend for this is CodeCov. It integrates with GitHub and things like that. If you generate coverage reports in your test code, it'll automatically consume your test coverage, and it can kind of visualize, you know, how much of your test is covered, see who's writing the most tests, what areas of your application are tested, these kinds of things. So it's quite nice. In terms of like, what does this look like? I have some example output from Pytest here. It's a little bit small. Maybe I should make it bigger. But you can see like, okay, what's the coverage percentage? Obviously, this is a toy project because you see a bunch of 100%. This is not a real application. But it basically just shows up like that. It's quite simple. A lot of times when people first see it, they're like, oh my God, but that's just because it's a large application. They'll usually split it by file or by package to show you what the coverage percentage is. And that's all it means, is how many lines or functions are covered. Questions about code coverage? What's up?
I have one question. In guess like when you do code coverage,
Hmm.
by default, test code is also included in the coverage.
Yeah.
So generally, do you think it is better to separate code coverage into separate sections, as in test application code coverage separately and test code coverage separately, or do you think it's okay to have both of them included?
So, good question. For benefit of the stream, the question is, a lot of test coverage calculations include the test code as part of the coverage calculations, which is usually not what you're looking to measure. So how do you handle that? Usually, because the absolute percentage is not useful, I usually don't worry about it. It's usually the diff between coverage reports that I care about. So usually I don't worry about it. Now, I haven't thought about it too deeply, so maybe I'm wrong, but since I usually just look at the diff, and because we usually look at it by number of functions, and you know what, I'm not 100% sure. I don't have a good answer for that. Like, my initial thought is I shouldn't worry about it, but I should think through it more and maybe do some number crunching to double check. So, disregard my answer. I'm not confident about it.
It's just like there's no right or wrong answer. I just want to hear your thoughts on it.
Yeah. I would say, like, so usually within our team, if we see the percentage go down by more than like 1%, or these days maybe more like 0.7 or 0.8%, then we're like, wait a second, something's up here. But beyond that, we don't worry about it too much. And then if we are noticing that there are stability problems, then we'll look at the detailed report to see like what areas of the application are covered. Or if we have some time to do auditing, or not auditing, to do like major refactor efforts, then we'll look, okay, what areas are lacking coverage? Because that usually means like that's an area we haven't done a lot of development in and could probably use a refactor. And in those cases, the percentage itself doesn't matter so much as what areas are covered. So because that's how my team uses it, we don't worry about that specific problem too much. But if your team focuses more on the actual percentage, like you have a hard limit of like we have to be above this percent kind of thing, then I could see that making sense. Yeah. Yep. Other questions? All right. So it seems, I think we're right on time. Any questions about this whole general testing scope? Because we're about to dive into the second half and write some code ourselves. Well, almost. Like 2 more slides. Going once. Going twice. All right, cool. All right, so Pytest time. What is Pytest? It is a testing framework for Python. You'll notice that the slide style is going to change a lot because I did not have enough time to switch to the new style. So this is going to be a lot more verbose. The main thing is it allows you to kind of group tests into suites. It has things like setup and teardown built in for you. It has a fixture system for you, which we'll explain in a minute. It has mocking built into it. There are other third-party libraries for doing mocking in Python, but Pytest's built-in mocking is usually good enough. It also has plugins, so you can add features to it like code coverage. So let's go ahead and dive in. So I recommend you clone this project. If you are more of a SSH clone person than an HTTP clone person, go ahead and change that. But this is just setting up a basic project. We're going to go ahead and take an example toy project, and we are going to write tests together. We're going to configure and install we're going to install and configure Pytest. We're going to write some tests. We're going to organize our code. It's going to be great. I'm just buying time while you follow the instructions on the screen. And you know what? I'm going to follow them too. Let me go ahead and get my environment set up here. Where am I? Okay, what's my state right now? Clean. Nope, wrong branch. All right, cool. What? Oh, yeah. Yeah, Windows is weird. So I tested all this before, except the Windows part. If the Windows part is wrong, let me know, we'll fix it. Because I originally created this presentation like maybe a year ago. And if anyone needs help, call out. Maybe I should change this to new, later. I'm just waiting until people look like they're to the point where they're bored and waiting. Oh, and I should get the, yes. Additionally, if you are on the Discord, I'm going to share the presentation slides and the GitHub repository on there to make it easier for you to follow along, because there is a lot of code. There's no point in just waiting for you to type all of it. It'll be easier to just copy paste and then read through it together. So we're going to go through that. So where is Saturday Hangouts? There it is. So today's slides. And where's the thing? Where? There it is. Okay. And the repository. Okay, there we go. And for the stream, if you're watching this in the future, the slides are in the video description, and then you can just copy and paste that link to the browser to get the repository. Okay. All right. Is anyone still working on getting set up? Okay. There we go. Okay. Who's still working on it? Good? All right. All right, so let's go forward then. So now that you've got the repository cloned down, let me just show it real quick. So, let me clean up my stuff here too. There we go. And now, oh, I didn't test actually running it. Well, we're gonna have a grand old time. Did I put a README? Yeah, I did. Okay. So, okay. So this repository is just a quick little API. Okay, it's using Fast API. If you're not familiar, it's just a really basic API. Not really basic. It's actually quite nice API system. So we can run it. Sets up a server on here. I can click this, and you can see, we get this output here. And I think there's an endpoint name. No, maybe names. I don't remember what. Yeah, there's an endpoint names. It gives you a list of names. Whatever. Okay. So that is what it sets up. And it's just if we look through resources here, we have like a name model, It uses SQL Alchemy, just which is basically an ORM for Python to a SQL database, and it's using I believe it's using a SQLite database backend. Simple routing. When we get the root of names, call the service to get to a list of DB names and then output what we just saw. Okay, pretty simple API stuff. Nothing. We're not going to spend too much time on it, but we do need to test this. Okay, so we need to test our get DB name by name, list DB names, these kinds of things. Okay, we do need to test these kinds of functions. We're just going to focus on listing the names from the database. These function names are kind of terrible. I should fix them, but whatever. And that's where we're going to focus today. So let's get back to it. My notes. I need my notes. Okay, right. So next up, usually you want to separate your test dependencies from your production dependencies because there's no reason in bloating your production deployment with a whole bunch of testing stuff. So there's a separate file, requirements-test.txt. Go ahead and install that one. That has Pytest built in and requests built in. Requests is a peer dependency of the API testing client that we're going to use. And so while that's running, it should only take a few moments, but while that's running, you can set up a new pyproject.toml file. This is actually kind of the future way of setting up a Python project. It's kind of similar to package.json for JavaScript folks. But we're only using it for the Pytest side of things right now. We haven't converted the full project to it. You want to basically put the following text into that file. And then I have a little bullet point at the bottom that explains the meaning of a lot of that stuff, but you don't need to worry about it. So I'll give everyone a moment to, you can either type that manually if you're a fast typist, or if you're on the Discord, you can just copy and paste, because this is not a test of your typing speed. So give everyone a moment to set that up. Python path tells Pytest that, like, hey, this current directory is where our testing should be done. The minimum version of Pytest is 6. That's probably really old. I haven't updated this in a while. There's some options, which I explained below. And then test paths, we're going to add some stuff to that in a couple of minutes. Okay, is everyone good? Okay, I see a couple of people still referencing and typing. For most projects, you can probably just copy and paste this. Okay. Just waiting a couple more minutes for people to type. All right, who all still? You good? All right. So so once you got that set up, we have everything we need to run Pytest. So if you just in your terminal just type Pytest and hit enter, it should just work. Okay? And you should see output like this. I originally did this on Windows? No. That's WSL. That's right. Yeah. Desktop part confused me. So is everyone able to run Pytest and gets output like this? What's up? Oh, raising your hand like yes. Sorry. Cool. All right. So far so good. You've run Pytest. That's a good start. And now let's configure it for our basic tests. So that's kind of the base. But now we're going to start with integration tests just because that's less code to write. And because we're using SQLite, so we don't have to set up any external services. We're just, a file is our external service, so we don't need to do anything special. So first decide on, usually what you would want to do is decide how you're going to do your testing. Some people use like a source directory and then they have a separate file or separate test directory and they do things that way to separate the packaging, which is actually the recommended way these days, but this repository is a little old. So we're going to do it the old way, which is not excellent. I don't recommend doing it this way, but it makes our example for today a little easier. In the app directory, just make a tests folder. Okay? And then within that test folder, make another folder called integration. This is where we're going to put our first integration test. Okay? And then once you've done that, you're going to take that folder path and add it to the test paths in your pyproject.toml. Oh, there's something I forgot to put in here. Cover it later. And then you'll want to make your test name. You know, let's just do this together. So let me pull up VS Code and clear stuff out so it's not confusing and terrifying. Okay. All right, so I'm going to replace this for a second. We're going to do it together. So in our app directory, we're going to make a new folder, tests. Okay. Whoops. Oh, I already made it. Oh. Okay, I'm going to delete this because I want to do this together. I thought I cleaned this out. All right, so we're going to make a new folder here. We're going to call it tests. Within that folder, we're going to make another folder. I could have just done test/integration, but I'm dumb sometimes. So we're going to have our integration test folder. Okay. Then in our, I want to have pyproject.toml. We're going to do that real quick. Pyproject.toml. And crap, I got to copy a bunch of stuff. Give me a second here. Oh no, where'd it go? Well, I'm going to have to go, crap. Well, give me a second, sorry. I screwed up. Yeah, there we go. Whoa, I thought I updated this. Okay, we'll have to fix that later. And then we're going to add our integration tests directory. So you'll want to add this part right here, this line. You're going to change test paths to look like this, okay? Because we're telling Pytest where our tests are. All right, has everyone got that? Cool. Now, another thing, something I forgot to put in the slides is that our integration tests folder, this needs to be a module. So we need to create an init.py. I will update the slides with this later. Okay, so don't forget to, whoa, and you should spell better than I do. I need to use more keyboard shortcuts. This is kind of a disgrace. There we go. And then once you've got those two things done, we can make our first test file. We're going to call it testname.py. I really cannot type. Okay. And then in this file, we're going to make a new function called test list names. And for now, we're just going to pass it. Okay? So far, so good? Has everyone got this?
Line 4 your toml equal sign.
Sorry?
Line 4 the toml file.
Oh, thank you. Thank you, thank you. All right, so once you've got that set up, you should be able to just do Pytest. Oh, oops. I cleaned up all of my stuff and then failed to set it back up. So sorry, give me just a second here. Okay, there we go. Yay! Okay, so you should have something like this. All right? And you'll notice here, it recognizes our test. And even though there's nothing in it, it passes. The green dot means pass, and all good. Everyone's got this so far? Cool. All right. So back to the presentation. Real quick, if you're new to testing, there's this big important concept called assertions. Most languages have this keyword called assert, or some function that does an assertion. And basically, it checks some condition. If the condition is false, it raises an error. That's all an assertion is. Okay? So I took a lot of bullet points just to explain that. All testing frameworks have some kind of assertion. They may not call it an assertion, but in essence, it's an assertion. It's if condition is false, raise error. Okay? So let's go ahead and write a quick dummy assertion. We're going to assert that 1 equals 1. Okay? And we're going to use this to assert, or assert is how Pytest checks that some value matches another. So if you want to check the output of a function and these kinds of things. So we can just do assert 1 equals 1. If you run this, you should be good. Okay? You don't have to type this part because we're going to remove it in a second anyway. Okay, but everyone understands assertions? So just to demonstrate, if I say something like 1 equals 2, right? You get this. It gives you an assertion error, highlights which line failed, highlights that it's an error, and shows you that the test failed. Okay? No surprises there. Oh, too many things. Okay. So, getting into writing an actual test, we're good on time. So we're testing an API server. Okay? This is a backend application. This is an API server. We need a client to test it. Remember, we're doing an integration test. Actually, you know what? This is not an integration test. This is a functional test. When I originally wrote this thing, it was wrong. So I apologize. This is actually a functional test because we're testing an endpoint. Man, that's disgraceful on my part, but whatever. Fast API provides a testing client for you, so we're just going to use that. A lot of different API frameworks do provide testing clients for you or recommend some third party to do it with. So we're going to go ahead and do that. Okay? So I need to figure out a better way to do this. Let's go ahead and set that up. So let's, from fastapi.testClient, import test client. This part you do want to follow along with if you are following along. I'm typing blind, so I really hope I'm right. Oh wow, 2 parts wrong. Okay. And then we want to do something like my typing blind is not bad. So this is a basic little test with FastAPI. Okay, FastAPI provides this test client object or class, whatever you want to call, or class that we can make a test client object with. And then you can just give it the HTTP operation and then the path, and it will simulate a request to that point. Again, this is not an integration test. I made a mistake. This is a functional test, but it's just an example idea. Okay. So if we run this, also I should add a blank line at the end. So this should run just grow. I tested this just before. Okay. No module HTTPX. I just tested. That's good. Oh, this is why you should do proper testing. I did not do proper testing because I was in a hurry, which I'm a bad PM. So I made a mistake. I updated, as I was cleaning stuff up over the presentation, I tested everything and then I got alerts that my dependencies were out of date. And then I'm like, I'll update dependencies. It'll be fine. There'll be no breaking changes. Famous last words. Of course there are breaking changes. So we're missing this, the test client for Fast API requires this HTTPX, which is a peer dependency, which we do not have installed. I apologize. So we're going to go here, and we're going to add HTTPX. Well, actually, before I do that, let me make sure that that's what it's called on PyPy. We don't want a nasty attack, so give me just a second. Let me verify this. Yes, it is just called HTTPX. Okay. So let's go ahead and do that. And install our requirements again. Actually, we can just install it directly. It's fine. All right, and now let's do Pytest. Cool, we're good. Oh, great. This is why you should test when you update your dependencies. But in any case, the test passes. I apologize for the warning. I'll fix that in the repository. But for now, we're just going to ignore it. Okay? So, again, what we've got here is we're creating a test client that's provided by Fast API, and we're just calling that as part of our test. All right? So far, so good. Any questions? Good? All right. So now, let's... Well, I should get my code off the screen. So now, let's make this more of a real test, okay? And I also put the directory structure up there just to kind of make sure stuff is clear. Your test folder doesn't actually need an init.py, but I put it there anyway. But this is a slightly more realistic test. What we're doing is we're calling the getNames endpoint, and we're just checking that it returns an HTTP 200, which is success. And then we want to make sure that we can deserialize the JSON into a proper object, and then we want to assert that the names output is in the result. Okay? Does that make sense? This is happy path testing. Okay? All right, so let's go ahead and try it. So what we're going to do... Whoa, oops. Okay, we have that already. So we're going to assert. And typing blind is a nightmare. Cool. So if you're not super familiar with Python, when you deserialize JSON, it creates a map. It creates a dictionary object, which in other languages would be called a map. Python has this keyword called in. It checks if a value exists in some collection. When you use in with a dictionary, it checks the keys of the dictionary and sees if the word before or the text before, or not necessarily text, if the hashable thing before in is one of the keys of the dictionary object. Okay, so we're checking that there's a key in the result called names. All right, does that make sense? I think I'm starting to lose some people here. But let's try it. So we do this. Cool, we get one test passing. Okay? And I'll fix that later. All right. So, questions about this test so far? And what kind of test is this? There are 2 correct answers. And I mentioned them both earlier.
A passing test.
True. 3 correct answers. Right? Anyone? Sorry? 4 correct answers.
Functional.
Functional test. Which one did you say? Not a unit test, because a unit test would be testing an individual function, and we're going to do that later. This is testing an endpoint. And so the endpoint, we'll have like a router, which then calls a controller, which then calls out to the database. So it's actually multiple functions in the code. So if we look at if we look at resources, resources name, and then if we look at routes, this is what defines this names endpoint, and this calls this list db names function. Oh, why is this not, what? Do we not have follow in VS Code? Or is this because I'm on WSL or something? That's really annoying, but anyway. And then this calls out to a database, so this is not a unit test. It calls a whole bunch of different functions.
So if the function has like some sub-functions or whatever, then it cannot be a unit test.
It can be a unit test if you define mocks. So when we talked about, so the question is this a unit test, and can it not be a unit test because it calls other functions? Most functions will call other functions, because that is usually how code works. So for unit tests, we would take those other functions being called by the function under test, and we would mock those. We'd basically replace them with a fake function to basically isolate the code that we're testing to only the function under test. Does that make a little more sense? We're going to have an example in a little bit after we finish this functional test. So this is a functional happy path test. Okay, we're testing a successful request with the inputs we expect and with the outputs we expect. So that's happy path. And then it's a functional test because we're testing a single system level operation, which is requesting a list of names via the API. Okay, so far so good?
Can we make it fail?
We could make it fail. So if we instead have it return something like names list instead of names, right? Our test expects that names is in the result, not names list. So if we make that change and then we run the test again, you'll see that it now fails. Oops. I actually need to change it in two places. Why did I not? Man, I gotta fix this. Okay. Sorry, this is when I was just first learning about this stuff, and it is all kinds of not great. But yeah, so assertion error, names is not in the result, which now has names list as the output. Okay, so that's an example of the test failing. Okay, this is no longer a happy path test because the expectation of correct output and the correct output of the test is not good. Okay, so let's get it back to the original state here. Okay, make sure it passes, and we're good. All right, so far so good? Cool. All right, so let's clear this out. Whoop. And so that's great, but what if we're running, let me get my notes here so I'm not like breaking my neck. What if we're running integration tests and need to prepare some kind of data and then clean it up, right? So maybe we want to, try, actually, what is my next example? Yeah. Maybe we want to, like this happy path test is actually not even a good happy path test because we're not testing that it's gotten names from the database, right? It's just giving an empty list of names. So even for a happy path test, it's pretty bad because we're not testing with any data. This is a functional test, so we should expect it to work with actual data. So in that case, we need to prepare that data for the test to return to us to check that the API server did get the data correctly from the database and did output it to the test client correctly. So we need to prepare that data and then clean it up. Pytest provides something called fixtures. And fixtures, you can pass them as parameters to your test function. And those fixtures can do your setup and tear down for you. Okay? So there's a whole bunch of different scopes which define when a fixture runs. Remember earlier I said that you can do setup before all of your tests or before each test or whatever, and you can do teardown the same. Fixtures work the same way. You can run a fixture at each tested function. You can run it at each tested class, module, package, session, whatever. Okay? We're not going to go into too much detail there. You can look at the docs for more details on these. Okay, so let's go ahead and try writing an example fixture that creates a sample name. Now, this is not using one of those nice fake data generating libraries. I just didn't have time to set that up. But we're going to generate a fake name, and we're going to put it into the database. Okay? And then we're going to output that fake name example to our testing function. Okay? And then we're going to delete the data. We're going to clean up after ourselves. Okay? So we define this function sample name, okay, and we give it that at fixture. That's an annotation that lets Pytest know, hey, this is a fixture. This is where we do setup and teardown. Please recognize this. By adding that annotation, now if we give sample name as a parameter name to one of our test functions, this function will be called. It will pause at this yield, okay? Actually, let me just go to the next. No. Wait, what? Why did I put that on a different slide? Okay. It'll pause at this yield here in the try, okay? And it will give execution flow back to the testing function. Okay, then the testing function will run. And then when the testing function finishes, the program flow will return to here and then continue from the yield point. So everything before yield is setup. Everything after yield is teardown. Okay? So that's why we wrap yield in a try, because if the test fails, we still want to do teardown, right? And then we do a finally, because we don't care if the test passes or fails. We want to clean up the data. So finally, we do our cleanup, which is deleting the name from the database. Okay? Does that make sense to everyone? This is a lot. Don't write this yourself. Just copy and paste it. Okay? So that's what I'm going to do. So I'm just going to go ahead and I'm going to go to the GitHub repository. So pro tip. In the GitHub repository, the answers are in this test branch. Okay? So if you just pop over here, you can get the final test code. So I'm just going to go ahead and do that. And except I moved it. So let me just, so if you go into conf test and the sample name fixture. So I'm just going to copy this guy. I'm going to toss it into here. And then we need to, this fixture uses a lot of new stuff. So we're going to need to, from Pytest, import fixture. And then import SQLite 3. And then there's one more. What is it? No, there's not one more. That one more comes later. Okay? So if we go back, nope, where is it? There it is. So I mentioned the yield stuff already. Again, before yield is setup, after yield is teardown. And then in our test list names function, we're going to do, so these look like spaces. They are underscores. It's just that Google Slides is not rendering it very well. So we put sample name, which is the name of our fixture, as an input. And then we're going to add this new logic to check the contents of names and make sure that our sample name is in the list. This sucks. This is bad code. Okay, anyway. Yeah. I don't know why I wrote it this way, man. This is I should have just rewrote this whole presentation. So this is, I reused an old presentation, and that old presentation was trash. God, that's embarrassing. Okay, so what we're going to do is sample name as an input. Okay, and then we're going to say that assert sample name. Wait a second, though. So sample name yields this object, which is kind of lame. Is that how I wrote the thing? No, because, right, it is an object. Okay. In result names. There we go. Oh. I think I know why I did this. Because it's checking for an object, not just a string.
Oh. Okay.
Let's see if it works.
But you're yielding names.
Huh?
You're yielding name, not names.
Yeah, but name is an object.
Oh, as in the
Or a dictionary.
It should be name, not names.
Where?
The result object that you're yielding has an ID name.
Yeah. So it should be name, not names.
No, so this names returns these these dictionaries.
Oh, object.
Yeah.
Oh.
So the output should be a dictionary of an ID and a name. Yeah.
Yeah, because the endpoint holds back names.
Right. So I apologize. I probably should have done a part.
How about we just see the output from the just the browser to see what's coming back?
Let's do that. So let's go ahead and run. Well, because I don't have this thing is. Oh, it does have. Give me a second. So this is Fast API. It is fancy.
Oh, yeah, Swagger, right?
Yes.
Oh, yeah, I forgot about that until just now as well.
Ah, crap. What's the default? I don't remember the default. Docs, it's docs. I remember. There we go. Okay.
Nice.
Oh, much better. So, names, outputs, like this format, okay? So, hence the name and ID, okay? I don't think Python does deep comparison of dictionaries. So I think that's why I had the loop and all that. So I should include that in the notes in the future. But basically, this is what we're checking for. Okay. So if we test it, let's go ahead and create a new name. So try it out. This new name is Beege. Okay. And execute. Did it run? There we go. So here's an example curl request. Here's the response. Beege is ID 1. And then if we go up to here and we list out the names, you can see we get names, name, Beege, ID 1. Okay? So far so good? Cool. Now, if you're like, wait, where did this UI come from? Did you code all this? Oh, God, no. Fast API provides this documentation for you. This is something called Swagger. It's really cool. If you're curious, you can Google it. Swagger's nice. That's why I use Fast API for everything now. Yeah. But going back to so this is what we expect. So going back to our application, and I don't think this works because I'm pretty sure I have to go check again, but I'm pretty sure Python doesn't do deep comparison of dictionary contents. Does anyone know for sure?
What are we trying to compare up there?
So we're trying to compare this, or we're trying to check if this exists in the list of names.
Oh, so sample name. Yeah.
This is sample
okay,
name.
Got it. So result names. Each of the entries is a dictionary, right?
Yep. Yeah, I don't think it does
yeah,
deep
we can't
comparison.
do that then,
Yeah, I thought so.
Yeah.
It's been a while. God, I miss writing code. All right, so name list equals result names. Okay, I'll do better if I just type blind. For name, let's say found sample. Found sample is false. This is Python, so capital F. For name in name list. Yep. if name is sample name, whoops, found sample is true, and then assert found sample. Okay, does that make sense? So far so good? Let's try it. We don't need the server anymore. Go! Oh, fail, why? Whoa. Generated name text. I tested this. Oh, I got it from the final code. That's why. Okay. Sorry, let me go back to the presentation here. Right. Sorry. This is why I should have just followed the presentation instead of trying to be fancy. So let's do... Okay, so there's our randomized data. We have to import. Okay, there we go. And I also got...
Try to put it back up.
Thank you. You know what, let me rewrite this fixture because this is just wrong. The final version is different from this version. So I apologize for the confusion. Give me just a second here. You know what? How about this?
Or can we just get it from app jump app? Can we just import it?
No, let's just do this. It's easier. Yeah. Okay, so I just copied this from the presentation. There we go. Yeah. So we connect to the database, we get our database cursor, we generate some fake name, we insert that fake name, we get the ID of the inserted fake name, we commit the change, print it just for kicks, then we output or we yield out that name for use in our test, and then after the test is completed, we go ahead and delete the name. So now, this should work. Man. Oh, right. And I need to, I got the environment variable for the database URL because I tried, it's so funny. When I wrote this, I was still trying to figure out how to do stuff well. And I tried to write it like production, but there's so many things that are not like production.
Do we need to export XC file? Okay, it's already done.
No, we're good. Okay, so that passes. So again, what we do here is we generate the fake name and put it into the database. We output this to our testing function, okay? And then we yield control to the testing function. The testing function takes in that dictionary, runs all this, all right, checks that the found name was in there, and then goes ahead and cleans it out and closes the database connection. So far, so good? Sorry that was a little bit rocky. I should follow the plan that I set rather than try to be fancy. So, all right. Going back to following the plan. So we did that. So that's great, but then if you have to include all these, what if you want to have one fixture shared between a bunch of tests? Like, let's say this API has like names and addresses, and that's terrible API design, but let's say it had a whole bunch of different modules, right? And we wanted to share fixtures between modules. You don't want to copy the fixture into each module, right? You want to have them in a shared place. You could do a whole bunch of imports, but that would be a pain. Instead, Pytest has a special file called conftest.py. And Pytest will read that before running any tests, automatically. That's just a special file name that it looks for, okay? Usually, I put a lot of my fixtures in there because the test code does not care about the fixtures, okay? The test code cares about testing the code. So I keep my fixtures in there, I keep my test code in the test files, and then everything's cool. So what we're gonna do is we're gonna move that fixture we made into a conf test file, Okay, and then we're going to do more stuff. Okay? So let's go ahead and do that. So let's go ahead and make a new file here. Conf_test.py. At this point, there's probably so much. People probably aren't following along at this point, so I'm just going to run through it. We're also running out of time. So let's go ahead and grab this guy, toss it in here, grab these guys, toss them in here as well. Okay, so far so good. Clean this up a little bit. Too many blank lines, very good. Trying to follow Pep 8 at least a little bit. Where's my presentation? Okay. So we moved that into a conf_test.py. And then, why is it? Oh, that's why. Okay. And then if we run it, we should see no change, right? It's just a refactor. So everything's cool. All right. Now you'll notice this is not importing that fixture stuff at all. Okay? Pytest automatically detected this conf_test.py file, automatically imports, automatically runs it, and then whatever's in there is available to our tests. Okay? So far so good? Cool. Getting real tight on time. So,
What happens if you have a name angle and name your test the same as a fixture?
so for purposes of the stream, the question was, what happens if you have a name collision where your fixture and your tests are named the same? Ideally, that should never happen. Pytest convention, actually, by default, Pytest will only recognize test functions that start with test underscore. And if you have fixtures starting with test underscore, that's kind of weird. So it's generally not supported or expected behavior. Good question, though.
Just
So-
a minor comment, but would it be a good idea to put test client under fixture and give it a scope of session?
Yes.
Aren't you?
So the question was the test client. Would it also be good to take the test client, move that to comp test, and make a fixture out of it and scope it to the entire session so that you just keep reusing the same client? Yes, it would be, and I think we do that. I don't entirely remember. It's been a while since I've done this part of the presentation. So let's run through it. But first off, fixtures can use fixtures. Okay, so that's really nice if you have some data that depends on other data and you don't want to have to like rewrite all of your setup stuff. So for example, let's say we had a profile entity, and a profile entity depends on a name entity. Well, we can just have a fixture for the name entity, make a fixture for the profile entity, and the name entity can just be an input to the profile. And so you can chain your fixtures and minimize code. Okay? But in this case, we're going to use our database connection often, and connecting and disconnecting for each test execution is slow, right? So we can move that out to a different fixture with a different scope. So we can connect to the database for the scope of the entire session, and then we can have different lower leveled scopes, like functional scopes, which run for every function. And then they don't have to connect and reconnect, connect and disconnect to the database each time. We do it once at the beginning, once at the end, done. So let's go ahead and do that real quick. So basically, I'm just going to copy and paste this because we are out of time.
Would it be better to just use, instead of DB current, like just use import from app from getDB and then just reuse that function for DB current?
So I don't want to import any code from the app
Okay.
because that's not the code under test.
Okay, got it.
Yeah. I mean, ideally. There are cases where that's not reasonable, but yeah.
Got it.
So what I've done here is we have this DB connection fixture that we scope for the whole session. So it runs at the beginning of the... Why did I do it like that? That is terrible. Okay, anyway. It runs at the beginning of the whole testing session, and that's it. It just runs once. And then we did a similar thing with the cursor. I shouldn't be closing the connection in the cursor function. That's just bad. Don't do that. But yeah. So, and then sample name takes in the connection and the cursor. Actually, I don't think it does. oh, it needs the connection to do the commit. So it takes in those as inputs, even though it itself is a fixture. You can just do that. It just works. Okay? Does that make sense? Yes, no, maybe? People, what's up? Oh, that was an okay sign. Cool. All right, so, what? Oh, okay. And then basically to just demonstrate this is the same as before, we can run it. Everything is cool. So now let's go ahead and get into our integration tests. We're going to go over mocks. So, I'm sorry, not integration tests, unit tests. So, you asked about unit tests with mocks and all that. We're going to do that now. Okay, so we're going to create a new unit test directory. Okay, we're also going to test this name function. All right, so let's go ahead and do that. So under tests, we're going to make a new folder. Unit, for our unit tests, we're going to make a module file. And we're going to make our test name.py. And then we're going to update our pyproject.toml to include our unit test folder. Okay. So that's all good. Let me clean up some stuff here. Okay. So all good. Now, oh, that's right, because I added this after the presentation. I didn't clean it up. So, Pytest has a built-in fixture called monkey patch. And monkey patch takes some function and basically junks whatever's there currently and replaces it with whatever function you make. Remember, that's kind of how I described mocks. Monkey patch is for mocking. Okay? So what we're going to do is we're going to do a unit test for this getName function, which gets an individual name. So if we go back to, if we go back to our Swagger, wait a second, I'm dumb. If we go back to our Swagger here, and we look at, we have this getName, get1name endpoint, where you give it a name ID, and it gives you the name for that ID. Okay, very simple, very basic. So what we're going to do is, we have this test get name success. Now I put success there to indicate that it's a happy path test. Okay, and then we take in this built-in monkey patch fixture. Okay, and in this case we're testing just this. What am I testing? Wait a second here. Ah, that's right. We're testing this getName function in the routes. Okay, so this getName function in our routes. Okay, it uses another function called getDBName. Okay, to given a database connection, request the name for a given ID. If the name is none, we give an exception. Otherwise, we return the name. Okay? Make sense so far? All right, so. Urgent? No. What? Someone's working on the weekend. That's not good. I will have to chat with them. Right. So what we do here is we generate a random ID. And then we make a sample expected name. Okay. Then this is our mock function. Okay. That getDBName, instead of running the actual getDBName function, we're going to run this function. Okay. This is our mock function. You'll see it does not connect to the database. It has an assertion built into it, right? We check to make sure that the input is correct. And then we otherwise just return an expected name. Okay. We're giving it fake output. All right. And then we use monkey patch to say, hey, that getDBName function, throw that away, replace it with this mock function. Okay? Because remember, our getName method here calls getDBName. So we're replacing this with our mock function here. Okay? So that's what this line does. This does the mocking. All right? And then we call getName, and we assert that the output of this matches the expected name. Okay? Does that make sense? Cool. So let's try. Did I save? Yes. Cool. So 2 tests pass. All right. So we can do something like, if you want to check that this mocked function was actually called, we can do something like assert false, right, which will fail. You see, the mock function was called in place of getDBName, and because it has this assert false, it failed. Okay? Does that make sense? Does that make sense for how mocking works? That was a little bit fast. If anyone's like, okay, I understood the words you said, but what the hell is mocking? If you're feeling like that, it's okay. Give me a signal. Okay, so mocking is basically you take some function, you replace it with some other function that generates fake data. In this case, this is that function that generates fake data. And so this right here replaces this getDBName function, which is called by our function under test, and replaces it with the fake function. Okay? Good? And this is how we do unit testing. So any dependencies of the function under test, you mock those out to make sure that the logic of the function under test is good. All right? So, we're out of time. Ah. Where are we? Oh, we're almost done. So, this is just explaining that. This is what I already explained. So, any questions about mocks?
Is there certain words
Is there a certain what?
notify what you wrote afterwards? Assert false. That will you added that assert false.
Oh, yeah.
Like it will be-
So the reason I added assert false was just to show that the mocked function, or the mock function, was being called instead of the original function. Because nothing is calling this directly. Okay? But because I'm replacing this getDBName function with this mock function, and our function under test is getName, getName calls getDBName. And because this is replaced with the mock function gets called. So I was demonstrating that this assert false, this assert false is showing that the mock function was called, because that fails the test. Does that make sense or not really?
I understood like when you were working with the assert false,
Mm.
it was like calling the mocking
Yep.
function.
Yep.
But when you added the false, it really like it does not valid anymore after you added that line.
Right. It causes the test to fail.
Yeah. So
Yeah.
I thought like assert false is not doing mocking. Like
No. It's the mock is still happening because this line is what's doing the mocking. This was just my way of demonstrating that the mock function was actually being called. Because if it was actually, you know what? The test will fail. The test will also fail if I don't mock, right? Because then we're not going to have this generated name. So if I, for example, get rid of this mock and I run the test, it fails because there's nothing in the database, so it returned none, which is actually a bug. It shouldn't return none. That's weird.
Prints work.
Sorry?
Print.
Print works if the test fails, which is actually really nice. So I can say print result, and then if I run the test, you'll see if we scroll up a bit, non-type object has no attribute query. Where the hell is it? Where is it? Oh, I should probably
Or you can raise an error and then just log it there.
No.
The reason I suggest that is because you can put a print on mock get DB name and another print on
Oh yeah.
get DB name and show that one you can like toggle between functions.
Yeah. So that works if yeah, thank you, Alex. That's a good way to demonstrate. So let's run this again. So the test failed. Where is my print? Where is my print? Oh man, where's my print? I don't know if I can search down here. Oh, slick. Ah, typing is hard. What? Bro. Well, I thought you could print on error. I guess not. That's super lame. I thought I've done this before.
I'm looking it up right now. You can pass the dash s flag when you do.
Ah, thank you.
I just looked it up. So can we try it again?
Yeah, I just did. Is it lowercase s?
Yeah. Let me double check. We have a lot of outputs on Stack Overflow, but yeah, and
This
and
is
then
this
the
is
fun-
why we test.
Yeah,
ChatGPT.
the funny thing is like the real funny thing is like somebody if it has a 25 output still doesn't love my print statements.
Yeah, that's weird. But anyway, when I do it in PyCharm, it works. But yeah, we were just trying to demonstrate that the mock works. But basically, the other way is to basically not show the mock, and we get an error because it's not the expected output. Also because there's no database connection. So it's like, what the hell are you doing? There's no database connection, and so it fails. But
So you're just basically replacing that get DB name function because you don't want it to go to the database.
exactly.
You want to just call this tiny little function that we call instead of connecting to the database. So they can restrict that test to only that function.
Exactly. Does that make sense to everyone? Thank you, Alex. Cool. So basically, any functions that are called by your function under test, you monkey patch them, you mock them, and then you're only testing the logic of your function under test. Okay? And monkey patch is how you do that in PyCharm.
What's the difference between making a comment or code?
Making what?
We have to change the actual code, right?
Yeah.
So I think it's not possible. So we have to test actual test without changing any code.
Right. So
This is kind of like segregation of the testing. Instead of test whole thing, just separate maybe small part.
right. That's the point of unit testing. Yeah. That's the whole purpose of unit testing. The purpose of unit testing is to test the logic within a single function. So let's say that function did a lot of complicated logic. Like let's say it was doing some sort of analysis stuff. And I just want to check that given some inputs, I get the correct output, right? That's what a unit test does. So it doesn't care if it can connect to the database properly. It doesn't care if this other function works properly. It just cares that given the correct inputs, do I get the correct output? Or given some incorrect input, does it handle the output properly? Or does it handle the problem?
Yeah, the purpose. But instead of doing this type of thing, maybe we can make it just commenting out that specific part, right?
Yeah, but then I have to go manually comment it out every time I test. Right? Whereas with this, because this mock, this is part of my committed code. Right? So now every time I want to test, I just do this one test, or I just do this one command, and I test all my code. I don't have to go comment this out, comment that out, replace this with some fake thing, right? My production code, my actual logic in my application remains the same. It does not change, right? And then my test code does all the stuff to isolate things properly and make sure that my unit tests are isolated to test the individual logic. And this way, my test code is separate from my application code. and I don't have to do anything special to do a production build. I just build it without the tests. I don't have to change any of the actual production code. And that's what makes things fast and efficient and easy. Does that answer your question and make sense?
Yeah, but after testing this, we have to restore the original code again, right?
Oh, no, the original code is not changed.
Not changed.
Right, so this monkey patching, this only lasts for the duration of this test. Replacing the original getDB name function with this mock function only happens during the run of this test. The original code is not changed. This get name function has not changed. We have not touched this.
Okay.
And that's what makes it nice.
Wait, Beege, on a separate note, I figured out how to get the prints working.
Okay.
Yeah, I just tested locally the dash capture equals in the code.
Oh, I think I've done that before, actually.
And the prints should work. Tested locally and it was working. But then you have to escape the first line because it appears on the first same line as.
What do you mean escape the first line?
Or like do a slash n like in front of the first print. Otherwise it displays on the same line.
Oh, I see. Oh, it doesn't do termination. Okay.
Hey, there it is.
Okay, cool. So, yeah, there's my model object. Cool. All right, well, good thing to know.
I think another good example would probably be for if you have a function that calls an API, let's say it gets the weather from someone else's service. I don't want to test their service because I assume the service is always running. And so, but I want to test my function, which gets the weather information and only gets the humidity information for 2 o'clock yesterday. And that's what this function does, because I'm really interested in 2 o'clock yesterday. I don't need to test the API service because that's whoever wrote that API, that's their problem. But I just want to test this function that gets that data from the API, make sure that it gets the 2 o'clock data from yesterday and returns it to me. So you're only testing that tiny bit without having to test their API. So mocking, not only maybe for unit testing, but can also be used in other tests as well.
Yep. Did everyone catch that? Cool. All right, so today, wait, was there anything else? No, that was it. So if you want to go further down the rabbit hole, there's more practices that you can read about. You can read about test-driven development, which is, in a nutshell, just writing your tests before you write your application code. So basically, you write code that matches the requirements, and then, or that defines the requirements, and then you write your code to pass your tests. Behavior-driven testing, where you kind of style your tests in terms of like user behaviors rather than like technical things. Acceptance-driven testing, which is kind of an extension of behavior-driven testing, but it's at the more broader user perspective. So it's kind of like at the end-to-end layer. And then combining test-driven development and pair programming, where you can kind of like have one person write a test, and then they give it to the other person. The person writes code to pass the test, and then they write some tests, and then the other person writes code to pass the test, and kind of back and forth, which is quite fun and nice. But you can read on that on your own. So thank you for sticking with us. We covered a lot today. We went over why testing, which is mainly talking points if you need to convince someone that testing is good. We went over the different types of tests, a whole bunch of them. We went over when to test and how to test. We talked about test coverage and basically how to manage it. Then we dove into Pytest. We set up and wrote a basic test. We tried messing with Pytest's fixtures to do setup and teardown. And we went over mocks and monkey patching. So that is it for today. If you want to look up additional resources, I have some here. There's a few more I plan on including. I'll update this list later. But beyond that, the code is there. I will link the video in the presentation once we finish here, or when I go update this later. And thank you for attending. If you have questions, you can email me there. I don't check the email terribly often, though, maybe like once a week. Your best chance of catching me is on Discord. And why I don't have the QR code there, but if you want to get on the Discord, just let me know and I can help you. We are a nonprofit. We do not yet have tax deductible donations. We still need to do the paperwork to get that done. I've been waiting on that for 2 weeks and I need to hurry now. But if you do want to donate to help offset the cost of things like dinner or whatever, you can donate to there. Additionally, thank you to Lunit, which is the company's building or company's office space that we're at now. Lunit is an AI medical company. They do cool stuff. And if you want to do more kind of in-depth kind of bootcamp stuff, Alex runs this group called W Coding. You can talk to him about that if you want to check out coding bootcamps. But beyond that, thank you for coming. Hope you had a good time, and let's go have some chicken. All right.